Alright, so I've cleared the screen and now we can continue on learning about coax cable. So in the last lesson we were talking a lot about how water and ultraviolet light can damage your coax and cause all kinds of problems. Another thing that can cause all kinds of problems in your station is a loose antenna connection. So make sure you really tighten your coax cable connectors. They have something, it lets you screw it in real tight. Make sure to screw it in real tight so that it's not loose. If it's loose, that can cause all sorts of problems, including, well, I'll wait till I write this on the board, and then I'll tell you what happens. Okay, loose antenna connections. And all these things can cause erratic changes in SWR readings, which leads me into the subject of SWR. Erratic changes in SWR readings. Alright, you may have heard me talking about SWR, but up until now I haven't really explained what it means, and now I'm going to do that. SWR is basically a measure of how well your radio is matched to your coax. Technically speaking, it's how well a load is matched to a transmission line. And what we're talking about here is how well your load, which is, the load is your antenna. So SWR is a measure of how well your antenna is matched to your transmission line. So the load is your antenna, is how well that's matched to the transmitter's impedance measured in your coax. And I know that sounds really technical, but that's how it's worded on the test. That's how I have to word it here. So the numbers in an SWR reading refer to impedance. So we're looking at the impedance between your antenna and your transmission line, or your antenna to the transmitter's impedance measured in your coax cable. So, and this also depends on the frequency of your radio. I'll explain more as we go along, so just hang in there for now. Anyway, they refer to impedance. If the impedance is the same on both ends, then you have a perfect match. SWR actually stands for standing wave ratio, so it's a ratio. So you have one impedance versus another impedance. So if it's the same on both ends, then you have a 1-to-1 ratio of impedance, or a 1-to-1 SWR. And the reason it's called standing wave ratio is because sometimes you actually have what we call a standing wave in your coax, where the radio wave just stands still in the coax because there's an impedance mismatch. And that's not a good thing. But if you have a 1-to-1 match, that's great. A 1-to-1 SWR ratio means you have a perfect impedance match between the antenna and the transmitter's impedance in the coax. Say if you have something like a 4-to-1 SWR reading, that means you have an impedance mismatch between your transmission line and antenna. So 4-to-1 or anything, really anything above 2-to-1 or 1.5, even above 1.5-to-1, that's not good. 1-to-1 is ideal. 1-to-1 is ideal. So when power is lost in your coax feed line, whether it's due to high SWR or due to something else like getting moisture in your coax, the lost power is usually turned into useless heat. And we're not performing ham radio in order to make the world hotter, so this is not a good thing. And this is one reason why high SWR is bad for your station. It causes your signals to get lost as heat. But there's other problems as well. High SWR can damage your radio, especially at high power. High SWR can really damage your radio. In fact, if the SWR gets too high, your radio will actually reduce its power output to protect itself in case of this high SWR. So you really want to make sure you have as close to a 1-to-1 ratio as possible. And there are a few things that affect the SWR. It really changes depending on your frequency. The frequency that you're transmitting on, the frequency of the signal going through your radio, that affects it as well. So a few ways you can alleviate the problem of SWR is you can sometimes change the length of your antenna. And I won't go into that too much now, but there's also something called an antenna tuner, which I'm going to talk about in a second, and that can also fix your high SWR problem. But anyway, as I said, having a high SWR can result in a lot of signal loss, in which case you would have to change the length of your antenna sometimes. Having a high SWR can result in a lot of signal loss in the coax cable. Signal loss. So when you have a low SWR, that means you can efficiently transfer power from the radio to the antenna with minimum losses in the coax cable. All right. Now, there are a few ways you can measure the SWR in your station, and one is with an antenna analyzer. An antenna analyzer analyzes the setup of an antenna, and when you hook it up to the antenna with your coax, it can tell you such things as the SWR at a certain frequency, what the SWR is at a certain frequency. And if the SWR is too high at a certain frequency, you might have to change the length of your antenna, because that does affect SWR. If your antenna is too long or too short, there will be an impedance mismatch, believe it or not. So it can also tell you, by the way, whether your antenna is resonant at a certain frequency. So in other words, if the antenna is optimized for use at that frequency. And actually, this is also another word for saying almost it has a 1-to-1 SWR. If it's resonant, then it will have a 1-to-1 SWR. That's optimal. If your antenna is not resonant at a certain frequency that you want to operate on, you can use the antenna analyzer to figure out how to adjust the antenna to make it resonant on that frequency. Again, changing the length. And then that's not the only way. You don't need to use an antenna analyzer. There's also special SWR meters. There are SWR meters that you can use to measure the SWR in your station. And the test might ask you about SWR meters, and especially about where you want to connect them to your station. So let's think about this for a second. SWR is a measure of the impedance match between the antenna and the transmitter impedance in the coax or in your coax, right? It's an impedance measure of the impedance match between the antenna and the transmitter impedance in your coax. So an SWR meter is going to have to connect to the antenna's coax, which automatically connects it to the antenna in order to measure this SWR. And again, the SWR is standing wave ratio for the standing waves in your coax, so it makes sense the SWR meter has to connect to the coax. So it's connected in series with the feed line. The SWR is connected to the coax cable, usually between the transmitter and the antenna. That's usually where the SWR meter is connected. And if you're confused about this at all, you can check the Gordon West manual. He has a very good explanation of all this, if any of this is confusing. But it's connected between your coax and your transmitter. All right. If you want, you can also use a directional watt meter instead of an SWR meter to find out if your feed line and antenna are properly matched. That might be something cool to know. The test also mentions it, but usually you would probably find it easier just to use an SWR meter and look for that perfect 1-to-1 ratio, which it should make pretty clear. All right, so as we've seen, high SWR can be a big problem in the ham shack, and that's where the antenna tuner comes in. So if for some reason you can't adjust the length of your antenna the right way, maybe you can't make it high enough because your homeowners association will get mad at you or something, you can use an antenna tuner. And the antenna tuner will tune your antenna in order to get the antenna's impedance to match the impedance of the transmitter. Give me one sec. I'm going to erase the board here. It's getting kind of crowded. All right. There we go. So antenna tuner. The antenna tuner will tune the antenna to get the antenna's impedance to match the transmitter's impedance, basically to fix the SWR problem. That's really all you need to know. The whole thing about impedance, it's a little technical, and you just need to know that for the exam. But once you're actually operating on ham radio, you can just worry about the SWR itself. You don't have to bother with impedance, which is a good thing. All right, so it tunes the antenna to fix your SWR problem. So the SWR, the antenna tuner will tune the antenna to get the impedances to match. Since SWR is impedance mismatch, the antenna tuner fixes your problems by tuning so that there is an impedance match. And by matching the impedances together, this reduces the SWR, allowing you to operate without any worries about your radio exploding or anything. By the way, an antenna tuner is also called an antenna coupler. Antenna coupler. This is a name you might see on the test. And This isn't on the exam, and I'm not going to write it on the screen, but just so you know, usually it's better to fix SWR by changing the length of your antenna as opposed to using an antenna tuner, because an antenna tuner can actually result, even though it fixes SWR, you can still have a lot of loss in your coax, so the signal, not all of it will get to the antenna. So it's usually better to change the length, but if that's not possible, an antenna tuner is a great solution. All right, so there's just one more thing I want to cover in this section, and that's a dummy load. We're going to learn about dummy loads. What is a dummy load? What is a dummy load? Kind of a funny name. So we know that an antenna is a type of load, or if you didn't, you know now. An antenna is also called a load. What is a dummy load? Well, a dummy load is kind of like a dummy antenna. So when you plug a dummy load into your radio, the transmitter sees it as a normal antenna, and you can transmit and do tests and all stuff like that. But since it's a dummy antenna, it doesn't actually transmit anything. It doesn't actually radiate any signals onto the airwaves. This is why it's a dummy antenna. It doesn't actually transmit anything. And why would you want a dummy antenna or a dummy load? Well, this can be really useful if you're trying to test out a piece of equipment and you need to transmit the radio without actually making a signal on the air. Say you're repairing your radio and you want to see whether it works now or not, but you don't want to actually have to transmit on the air because then you'll have to identify, and that's sort of a pain. Instead of hooking the radio up to a real antenna, just hook it up to a dummy load. Dummy loads are useful for testing equipment. All right, now one little note here. The test currently has a question that asks what a dummy load is made out of, what it consists of. And there are several choices. You're going to get a choice A is a high gain amplifier and a TR switch. I'm just telling you this. I don't have to, I'm not going to put it up on the screen. But choice B is a non-inductive resistor and a heat sink. C is a low voltage power supply and a DC relay. D, a 50 ohm reactance used to terminate a transmission line. And this sounds really technical and really complicated, so I'm just going to make it really simple for you. If the test asks you what a dummy load is made out of, just choose the choice that has the words heat sink in it. Because understanding why a dummy load is made of the components it is beyond the scope of this course. It isn't even explained in your Gordon West manual. But all you need to remember is that a dummy load needs a heat sink. Think about it. A dummy load has to absorb RF power when you transmit into it, right? The RF power coming out of your radio doesn't go on the air, so where does it go? And the answer is it's radiated as heat. The dummy load radiates it all as heat. And thus the dummy load gets hot and it needs a heat sink. So that's all you have to remember to answer this question. It makes sense dummy loads would get pretty hot. And that's it for this section on coax. There is no addendum video for this section, as you may have noticed. So at this point, you can go on to study this section in the Gordon West manual, take the quiz like normal. And then on next section 20, safety first, is the last section in the Gordon West manual, and after that we'll end our journey together, and hopefully you will get a ham radio license. So I will see you in section 20. Bye-bye.